form, how they die, the cool stars in our galaxy, and other cool star-related things. As always, if you have any questions, make sure you comment in the chat to the side, or if you're watching this later and not live, feel free to add your questions to the comments below. Anything else, Max?
I would say some of the stuff we are going to cover you can see with your own eyes, maybe even tonight if it's not super cloudy out. But some of the stuff is also stuff we'll be covering where space organizations had used super expensive telescopes to be able to see. So we're going to kind of give you a little bit of both worlds. Some stuff you might be able to do on your own, and then some stuff you may have only heard of from organizations similar to NASA.
That's right. Awesome. So today we're going to be using the program Stellarium to fly around. It's a free program that you can download. I'm using the downloaded version, and I'm going to share my screen. Here we are. So you all should be able to see this. Right now it is set to be in the middle of Seattle. Those are the coordinates set. As you can see with this picture here, I don't think this picture was taken in the middle of Seattle, but that's okay. It's just a general picture for everything. And what I'm going to do is I'm going to speed up time here. So we're going to let our sun right here start to set. Our sun is a star. And as it sets, as we turn to darkness, I figure we can talk a little bit about what stars are and why they're different from planets. Max, do you want to start on that?
Yeah. So stars, I always think of are kind of those bright shining dots that we see really mostly at night. We do, as Marissa, you said, see one during the day. We call that the sun. But what categorizes a star rather than a planet or a moon or an asteroid or a comet or anything else is how much mass it has. So it is just so much bigger than anything we are really familiar with here on planet Earth. And so because of that size, it creates something called nuclear fusion. And that allows it to kind of twinkle, kind of be the source of light. And Marissa, would you like to go into fusion a little bit more?
Yeah, I'd love to. So to talk about fusion, first I want to talk a little bit about atoms. Atoms are the tiny little things that make up everything. I'm made of atoms, you're made of atoms. Everything around you is made of atoms. Atoms have little things called electrons in them. And I'm going to talk about one kind of atom in particular, and that's the atom that hydrogen is made out of. Hydrogen is a gas. Our sun is made of hydrogen. And hydrogen has one single electron. And fusion is what happens when those atoms get squished together. And to talk about that, hey, Max, have you ever gone swimming before?
I have.
You have? Okay, so imagine you're... You're hoping to do it soon? So imagine, Max, you are swimming. Say you're at the local pool. And imagine you swim down to the very bottom of the pool so you can touch the bottom. When you're down at the bottom of the pool, can you feel the weight of the water over top of you?
I feel like I almost feel it in kind of my ears.
Kind of feel it in your ears. Yeah, folks at home, you might recognize this as well. So when you're down at the bottom of a pool, you're feeling the pressure of the water above you. That pressure is pushing down on you and pushing down on your ears. Now, stars are so big. They're made of all this gas. The deeper you go into a star, the deeper you go into that gas, the pressure of it, the weight of that gas pushes down. And the middle of the star has so much pressure. It's pushing so hard that it can literally take two hydrogen atoms and smush them together. Now, when you smush two hydrogen atoms into one, you're combining them. And each of those electrons, here's one hydrogen atom with one electron, here's another hydrogen atom with another electron, they get smushed together into one atom with two electrons inside. And that creates something totally different. That creates the atom of something called helium. You might know of helium at a birthday party in a balloon, or if you inhale it and you talk, your voice sounds funny. Helium is made when you squish two hydrogen atoms together. But to do this, it gives off so much energy that, as Max was saying, is what causes a star to give off all this energy to shine, and to be really, 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 really hot. So that's fusion.
Now, Marissa, something that I kind of found out that is kind of interesting is that the word helium comes from the word Helios, so the Greek god of the sun, Helios, because we don't find naturally occurring helium here on Earth.
I didn't know that. That's really good. Helium from Helios. So that's what our sun is made out of. It's made out of hydrogen, mostly around the outside, and it's got some helium in the middle where that hydrogen is squishing together. And that's what all stars are made out of. That's also what some of the bigger planets are made out of too. If you think of Jupiter, Jupiter is made out of hydrogen, but it's not quite big enough. It's not big enough to have enough pressure in the middle to squish that hydrogen together and turn it into a star. All right, sweet. So we've talked a little bit about what makes a star. I figured we could move on into some different types of stars, maybe fly around and look at some more stars in our galaxy other than the sun. Max, did you want to bring up that diagram real quick?
Of course.
So Max is going to bring up a diagram. Oh, go ahead.
Marissa is going to, we're going to kind of switch to a different screen, something that a lot of scientists like to use to categorize different stars. Because I was about, just like there are different types of planets, there are different types of stars as well. Oops.
Some technical difficulties. There we go.
Now, right along here is something that we identify as the main sequence, and it's kind of listed right here. And right in the middle is our sun. So our sun is a pretty average star. And so it will kind of, as time goes on, kind of continue to follow this main sequence. But as you might notice, there are different types of stars. Some things we might call giants, some things we might call dwarfs, or even things that are super, super big, things that we call supergiants.
All right, so what we're going to do, let me get my screen back here. What we're going to do is we're going to fly around and we're going to look at some supergiants. We're going to look at some white dwarfs. We're going to look at some different kinds of stars in our own galaxy. So, dun, dun, dun. Here we are, and we're back with me. Max, what do you think we should start with?
So I mentioned that the sun will eventually change. So what we predict, what we think will happen, is that the sun will turn into a red giant. What red giants are we able to see maybe in the sky tonight?
There's one I can think of. Let's take a look at Arcturus. Arcturus is in the constellation Boötes, or Bootes. I'm never quite sure how to pronounce it properly. Here it is right here. Now in this picture, it doesn't look super red, but it is a star that's reaching the end of its life. As it starts to use up its fuel, it gets really big. It turns into a red giant. And eventually it's going to sort of explode and collapse. But that won't be for a very long time, probably. And that's what our sun is going to do as well. So Arcturus, like Max was saying, is like our sun, but a bit older and reaching the end of its star life. Max, anything you want to add on Arcturus here?
We categorize it as a red giant, and something that I always think was tricky for me to kind of comprehend. We normally associate red things as very hot and blue things as really cold, like the temperature of water. Stars are almost the exact opposite. So a blue star is burning very, very brightly and is very, very, very hot. As far as stars go, a red star like Arcturus or other red giants are going to be cold or colder. Now, they are still super duper hot if we try to go there.
That's true.
But as far as stars go, they are colder than or more likely to be colder than our sun.
That's a good point. Hey, Max, do you want to see a blue star?
I would like to see a blue star.
Let's visit. Oop, there we are. Deneb. This is a star in the constellation Cygnus the Swan, and it is what we call a blue supergiant. So it is a really, really big, really hot blue star. And the cool thing about blue supergiants is they don't live very long. They're so big that they go unstable and supernova pretty quickly in terms of star years, which for us is still a long time. But because they live fast and they die young, scientists call them the rock and roll stars, which I think is kind of funny. So this is Deneb right here. I'm going to zoom out a little bit, and I'm going to actually bring up the constellation pictures here just so you can see where it is in this constellation. We can see a few nebulas around it as well. We'll get into those later. Here it is right here in the Swan constellation. All right, I can think of about 2 more stars I wanted to look at. Max, what do you think?
Well, so something I want to point out is that both Deneb and Arcturus are known as giant stars. And so those are bigger stars, as we kind of mentioned earlier. Now, Deneb is, to my knowledge, bigger than Arcturus. It's considered a supergiant. And so
Yeah.
it's not a red supergiant, so it's burning pretty brightly, and it is super hot. But let's take a look at another supergiant, maybe arguably the most popular, most well-known supergiant in the night sky.
That sounds good. Let's see if I can spell it right. Betelgeuse, or Beetlejuice. There we go. Excellent. We can see it's in the constellation of Orion right here, right in his armpit. And we can see this one actually does look pretty orange. It looks a bit more orange than the other ones we saw. And I've noticed personally, if I go outside and I look for Betelgeuse in the night sky, it looks red to me. I don't know about you, Max.
Yep.
That's definitely something I've noticed. Yeah.
I would agree that is a very noticeable red star that you can even see with your own eyes.
Now, Max, is there anything you wanted to say about Betelgeuse?
Yes and no. I always kind of want to phrase it to people, just be sure you don't say it 3 times. Normally there's a little generational gap there. But Betelgeuse, as you mentioned, is a supergiant. So it is crazy, crazy big. If, from what I understand is correct, if you swapped Betelgeuse with where the sun is, it would reach almost to Jupiter. So we would be sitting inside of Betelgeuse right now.
That doesn't sound very comfortable.
I don't think comfortable at all.
Yeah.
Now with Betelgeuse, because it's bigger, it's going to have a little bit more of a different life cycle, a little different star death than our sun, but we'll kind of come across that later in the show.
Yeah. Betelgeuse is a star that is going to go supernova at some point. And as Max said, we'll go into what that means and what a supernova is later. But because it is close enough for us to see it right up there, this is a star that humans will be able to witness the supernova whenever it happens, which, could be tomorrow or could be in several hundred years. It could have already happened. Betelgeuse is around 600 light years away, which means the light we're seeing from Betelgeuse tonight is the light it was giving off 600 years ago. So 100 years ago, it might have already exploded, but it'll take another 500 for that light to reach us. Just kind of amazing to think about.
Yeah.
All right, sweet. I can think of one more I wanted to point out, and it is right next door to Betelgeuse. Here's Betelgeuse right here, and if we sort of draw a line over here, we're looking at Sirius, the dog star. I'm going to zoom in on him. There we go. Sirius is the brightest star we can see in the night sky. It is not because it's the biggest star, but because it's fairly close to us.
Mhm.
You might recognize the name from Harry Potter. There are a lot of Harry Potter names in the night sky. There's another book I read that wasn't Harry Potter called Dog's Body, I think. It's by Diana Wynne Jones, and it's about Sirius the dog star getting turned into a dog on Earth. It's really good.
Oh,
That's, I guess,
cool.
Marissa's book corner. I don't know. I think I mentioned The Martian a few weeks ago. It's a new segment we're trying out. Um,
Mhm.
so the reason I'm pointing out Sirius though isn't because of the star you're seeing right here. It's because it's a binary star. So there's two stars here. There's Sirius A, which is the big bright one we're seeing, and there's Sirius B, which you can't really see because it is a lot dimmer. And it's something we call a white dwarf, which basically means it used to be a much bigger star, but it went through stellar death. It lost all of its outer layers, and what's left is the core. And the core of that star is a white dwarf. It's small, but it's really, really, really dense. It's about the size. They think it's about the size of planet Earth. This star, but it's way, way denser because it's got all this material packed in really, really tight. Um, and because white stars are almost like I want to say like the zombie star, like they're not creating any new energy. That light giving off is going to dim and fade over time. Um, uh, yeah, so because of that, it's I think zombie star is the right way of saying it. Um, yeah. Max, did you have anything to add about white dwarfs?
Well,
We'll talk a
and
bit
the
more about them later.
mhm.
Sorry.
And dwarfs are kind of the opposite of a giant. So those giant stars we've mentioned are very, very big. Dwarfs, as Marissa said, are much smaller. So this white dwarf, Sirius B, is about the size of the Earth, but it still has the same amount of stuff or like this similar gravitational pull as the sun. It's just super duper tight together, which makes these things really unique.
Yeah, and one day I believe our sun will turn into a white dwarf, they think. Um, and we'll go a bit more into that when we talk about stellar death. But first, I want to talk about how stars form. So, let's zoom out here from Sirius A and B. There we are. And Max, do you want to talk a little bit about nebulas?
Sure. So nebula, some some people are familiar with them, some not. I remember it seemed like a word I had heard a lot before I really realized what it was. Um, so a nebula is just a big cloud of gas and dust. And there's different types of nebulas too. The one we're going to focus on first are known as stellar nurseries. So, kind of from this big nebula, stars are able to form. And so from these big clouds of gas and dust, all those molecules, those atoms that Marissa mentioned earlier, kind of start bumping into each other and they eventually form into new stars. And these huge nebulas are light years across. Like, they're huge on their own. And what nebula are we looking at right now?
We're looking at the Orion Nebula, which real quick, I want to point out, this is one that you can see from Earth. If you look up here, I'm going to zoom out a bit here so we can look at the constellation of Orion. Here is his belt right here. Here's sort of his legs, his armpits. If you look at this right here, it's a sword. It kind of looks like there's 3 stars in a row, 1, 2, 3, but the middle one you're seeing is not actually a star. It's a nebula. If we zoom in a lot closer, you can see that. So a bit more about this nebula. As Max was saying, it's a place where stars form. This one right here, it's kind of hard to see in this picture, but there's 4 really big, really bright stars right in the middle of it in sort of a trapezoid shape. They're called the trapezium, trapezoid. And then on the outside here, there's a bunch of other stars we can see. These stars are forming and they're sort of drifting off in these directions, off over this way, to start their journeys through our galaxy. The other really cool thing about this nebula is it was actually spotted by the ancient Mayans. The Mayan people saw this nebula, and their word for it translated meant the cosmic fires of creation, which is amazing to me because that's literally what it was. These folks who, didn't have the modern telescopes were able to see this and call it by the name for what it was, a place where stars are born, which I think is amazing. Let's zoom out a little bit here. Are there any other nebulas you want to look at, Max?
Yeah, and I think we kind of pointed out how the Orion Nebula, I would say, is one you're able to see, kind of depending on the weather, depending on if you live in a city or not. One that is pretty similar to it, a similar nebula to the Orion Nebula, but is still in the constellation of Orion, is known as the Horsehead Nebula. Now, the difference in the name, Orion is named because of where it's located. It's in the constellation of Orion. Horsehead is more referring to what the constellation, that big cloud, looks like.
It's a little upside down, but this kind of looks like a horse's head to me.
Mm-hmm.
This is a really cool picture that I like to show because you can really see where those newborn baby stars are forming and what direction they're going in. So go ahead, everybody, take a look at this sort of line right here. This is sort of where that red stuff starts, and that red stuff is the gas and the dust in space. If you look below that line, notice the distances between stars. There's a lot of distances between these stars here, right? They're kind of spread out. Now, if you look at the other side of that line, notice how small of distances there are between stars all the way out to here. All these stars are forming here, and they're all moving in this direction, over this way. Now, speaking of stars forming and moving in directions, I thought maybe we could look at a few clusters of stars. Max, do you have a favorite cluster you want to see?
I do. Before we kind of jump to that, I like to point out who discovered the Horsehead Nebula.
Oh, yeah.
So there was an astronomy professor at Harvard. His name was Edward, I think it was Pickering. And he was very frustrated with his male assistants. They just weren't doing a good enough job. So he told them, I bet my Scottish maid could do a better job than all of you combined. Now, that Scottish maid, Williamina Fleming, went on to discover like 58 other nebulas. I think it was like 10 supernovas, and then like over 300 stars. And she was one
That's
of
amazing.
the first women to ever be like her occupation. She got paid to be a scientist. One of the first ever people was almost because there was a professor who wanted to kind of prove that his maid could do a better job than any of his male assistants.
Good for her.
Yeah.
That's awesome.
Marissa, before we move on, so we mentioned the pink cloud on the Horsehead Nebula. I think I have an idea, but it looks like kind of a browner group, a browner cloud above that.
Right up here.
If you zoom in again, it just looks like a different color. I think that's just a different type of gas.
Are you seeing it, Max?
Yeah, so it's right above that very bright star.
So right up here?
Mm-hmm.
Yeah, I believe that would just be another kind of gas or dust. That is a really bright star right there. Wow.
Mm-hmm. But we kind of mentioned nebulas are where a lot of stars form. And so given, a very, very long time, sometimes millions of years, they might form into some sort of cluster. And so what cluster will we be looking at first?
There are a few different ones, but I thought we'd go with a pretty famous, well-known one. Let's see if I can remember to spell this one. P-L-E-I? Nope, it's I-E. Nope. There it is. I before E, except in Pleiades, I guess. All right. So we are taking a look at what is often called the Seven Sisters. In Japan, it's called Subaru. Many, many different names for it across the world, across cultures, across time. Actually, I'm going to zoom back out for a moment here so we can get, oh, it's right next to the sun. It looks almost like a little tiny dipper right here. But as we get close, we can see there's actually a lot of stars there. The ancient Mayans called this 200 boys, 400 boys. I always forget the number of boys. I think 200 boys, which is another pretty cool thing about the Mayans because from Earth it looks like there's 6 or 7, but they knew there was more than that. So cluster, there's two kinds of clusters. There's open clusters and there's globular clusters, which is kind of fun to say. What we're looking at right here is called an open cluster. This is a group of stars that formed because of a nebula, and now they are all moving out across space. They're moving away from each other. And in a really, really long time, these stars, the Pleiades, they won't look the same anymore. That nice little miniature dipper there will spread out, and they'll just become other lights in the sky. Max, did you have anything you wanted to say about the Pleiades or open clusters in general?
Yeah, so open clusters are relatively young stars. And so the Pleiades, I want to say, are like 100 million years old. So whenever I try to find, yeah, fairly young. Whenever I try to find them at night, I always kind of like have to remind myself that I am looking at a star cluster that I can see right now that the dinosaurs couldn't.
Wow.
But as Marissa said, this is only one type of cluster. So these are fairly young stars, where the other type, the globular cluster, kind of the more fun word to say, is much older stars.
This one has the very fancy name of M5. Also looks like it's called the Rose Cluster, though, which is nice. So as we zoom in on this, we'll see it looks a lot different from the Pleiades. Max, do you want to talk a bit about globular clusters?
Yeah, so they're very different than the cluster we were just looking at. Normally, globular clusters are a lot older. You'll see a lot redder stars in there. You normally see more stars than even the Pleiades, so on the level of hundreds, thousands, tens of thousands, maybe even hundreds of thousands of stars we are looking at right now. And most globular clusters are going to be towards the center of a galaxy, towards the center of a galaxy, like say the Milky Way, whereas open clusters like the Pleiades are going to be farther out, farther towards the edge, kind of the outskirts of a galaxy like the Milky Way.
Yeah, globular clusters are really cool. They're gonna stay like that. Like they're not gonna spread out and move away. They seem to just sort of stay put, which is pretty neat. Sweet. So we've talked a bit about how stars form, a little bit about the journeys they take or they don't take, depending on the kind of cluster they're in, across our galaxy, across the sky. We've got about 10 minutes left of this show, so let's talk about stellar demise. Let's talk about what happens to stars when they reach the end of their lives.
Mm-hmm.
So we talked a little bit already about red giants, about white dwarfs, about what happens there. I'm gonna fly us back to the sun to get a look at it. There's a couple different things that happen when stars use up all of their fuel. There's sort of, I don't know if I'd consider it the normal way, what's going to happen to our sun. And then there's the more exciting way, which is what's going to happen to Beetlejuice, some of the other big ones. So let's center in on the sun. Ooh. And let's zoom in here. So I talked about fusion earlier, about how the energy that stars have comes from that immense pressure and heat in the middle of them, squishing two hydrogen atoms together until they become a helium atom. Now, after a while, they start to use up their fuel, right? There's only so much hydrogen they have, and depending on how big the star is, they can go down a couple of different paths. Our sun is sort of a moderate medium-sized star, and it's big enough that once it uses up its hydrogen fuel, it can actually start to burn helium. It can start to force that helium together and fuse it into the next sort of element, into carbon. The two electrons in two different heliums combine to 4 electrons, one atom that makes carbon. But the thing is, once it hits that phase, that's when the star starts to reach the end of its time. Once it starts to burn other stuff other than hydrogen, it starts to expand. It starts to get a lot bigger. We call that a red giant. It's going to get really, really big, and then it's going to, and Max, you might need to fill in here because I always kind of forget all the steps here, but it gets really, really big. And then it sort of sloughs off. It sort of loses its outer layer. Its outer layer sort of floats off and becomes something called a planetary nebula, which does not make planets. I don't know why it's called a planetary nebula because planets are not involved. But that sort of floats out and becomes this cloud of extra gas and stuff around it, and the core is left behind as a white dwarf. And we actually have some examples of this to sort of show you what that looks like.
Mm-hmm. So a couple of things. One, I like this image. It looks like you could just see some of the sunspots on the sun, some areas.
Yeah.
But yeah, so from what I understand, when we go from a huge star like a red giant to a dwarf star, that is where the pressure to kind of collapse is greater than the fusion that is occurring to push it out. So right now, our sun is very stable. It's very normal because it's creating energy to push out, and there's gravity to push it down. And it's kind of a balance. But when a red giant happens and it runs out of fuel, the gravity will kind of collapse it into an image we see right now, into a planetary nebula.
Yeah.
Now, I think it gets its name because we are looking at a very high resolution, multiple wavelength image of a planetary nebula, whereas people 200-300 years ago just saw a blip through a telescope that they thought looked like a planet.
That makes sense. So this image is nice right here because you can really see this is that ring. You can see how the outside of this star sort of floated out into this ring here. And that white dot you're seeing in the middle there is the white dwarf. That's the core right there, left over, right in the middle.
Yeah, that's nuts. Different colors, I think, are different gases as well.
Yeah, that's right. So I believe, right, Max, that this is not the actual color of it in space. It's colorized to help us see the different kinds of gases there. Yeah?
Yeah, I wish it looked like that color.
That'd be pretty cool. Awesome. Oh man, we're running low on time. So that is sort of the normal stellar death. That's what's going to happen to our sun, but in a very, very long time. So you don't need to pack up your bags yet. You've got plenty of time there. Now the more exciting one is what Beetlejuice is going to do. Let's fly back over to it. Beetlejuice.
And so this is kind of referring back to what we talked about earlier. So our star, pretty normal. It's thought to eventually become a planetary nebula. A Beetlejuice, remember, is so much bigger than our own sun. It's a huge star. It's called a supergiant. So when it collapses, it's going to create a huge kind of explosion that we refer to as a supernova.
That's right. Yeah. So this star is so big, and I was saying earlier that our sun is big enough that after it uses up its hydrogen, it can start to use up its helium. The bigger the star, the more it can fuse other things. We've got a picture of that. Max, did you want to show that picture?
Sure, I can show it quick.
Okay. I'm going to stop my sharing here for a second.
Yeah.
Swap back.
And then if I do this,
There we go.
Yep. So Marissa mentioned that the outer edge is going to be hydrogen. And then we go down to helium. From helium, these huge stars go to carbon, then neon, oxygen, silicon, and then this last one is an important one, and that's iron, Fe. Now, iron is going to be important because the last kind of stable, the largest element that's stable enough for stars to be able to form. But if you look on a chemistry periodic table, there are bigger elements. There are other elements past iron, and those are created because of supernovas.
Here we go. Yeah, so as you saw, there are all those different layers going down. Once it hits iron, it can't fuse anymore. But once it uses up its hydrogen, it does start to get bigger and redder. So as it's going through all those different stages, it's getting bigger and bigger, turning it into a red giant, or supergiant, excuse me. And after that, it explodes into a supernova. And from there, it can do a couple of things. So let me, what's the best way to describe it? First, I'm going to bring us to a picture. Let's go check out the remains of a supernova. There we are. Oh, it's right next door. Excellent. So this right here is the Crab Nebula, and this is the remains of a supernova that happened a really long time ago. This happened in ancient China. There were records that we can see now about something called a visitor star. Basically, there was a really, really bright star that appeared in the nighttime sky, but they could even see it in the daytime sky. It flared up. It was there for a little while, and then it went away. And the ancient Chinese were really, really good astronomers. They were very good at noticing changes in the sky and recording those. So then, much later, once we started to develop telescopes, someone happened to look up in that area of the sky, and they saw this. So they were able to piece together what the ancient Chinese saw with what they see now to realize that this was once a star. It was a star that expanded really, really big, became a red supergiant, and exploded into a supernova, and it left this.
Mm-hmm.
Max, is there anything you wanted to add about this?
Yeah, so from that explosion, it becomes very bright, enough to pretty much outshine anything else you would see at night. And to my knowledge, the ancient Chinese astronomers were even able to notice it during the day.
Mm-hmm.
Now, hundreds of years go by, and an astronomer looks at this and he wants to come up with a name for it. He calls it the Crab Nebula. Now, I don't really see a crab. Legend has it he tried to draw it out and his drawing looked like a crab. I always kind of say I don't know what the nebula looks like or his artistic ability, but ever since we've called it the Crab Nebula.
It's a good name. I like it. So we've reached almost the end of a star's life, but depending on the size of the star, there is another step that can happen. So if you've got a really, really big star, maybe something called a hypergiant, hypergiants exist, which do a hypernova, I guess, which is a lot to think about. Very, very big explosion. Something can happen after they expel off that outside layer, and as the insides of them start to collapse. If they're big enough, they can collapse so much that they become one of two things. They can become a neutron star, which isn't really a star anymore. It's a bunch of neutrons all packed really, really tight together. Or two, it can become a black hole. This is how stellar black holes are formed. Basically, what's left over from the star packed so tightly together, it's so much mass in such a tiny, tiny little space that it creates an absurd amount of gravity. Because of that gravity can pull in all the things around it, including mass from stars next door. Yeah, I don't believe Beetlejuice is going to become a black hole. I don't believe it's quite big enough, so that's not anything we have to worry about. Black holes are interesting because they are black holes, so we can't. It's hard. It's very, very hard for us to get a picture of them. There's one picture so far that's been taken of a black hole, and it really takes in the light around the black hole, not the hole itself.
And
Yeah.
I think that image even was more than just light that we can see. It was other types of wavelengths like infrared or X-ray
Yeah.
or radio waves. I'd have to double check kind of which one it is.
Cool. All right, so we have reached basically the end of the show. Max, are there any questions that people had that we wanted to go over?
I think one kind of our final question we've got, and I don't really know the answer of this. We talked about how stars, based off of their color, might relate to their temperature. What type of star is the coldest?
The coldest type of star. That's a good question, and I think there's a couple of different answers to it because There are colder stars. The colder stars would be the redder stars. But there's also something called a brown dwarf, which isn't quite a star. A brown dwarf is sort of in between a really, really big gas giant like Jupiter. Jupiter's a really, really big gas giant planet, and in between a really small star. It's something that's not quite a planet because it's so big, but it's not quite a star because it's not quite big enough for hydrogen fusion to happen in the middle of it. I think there's some ideas that it might be able to fuse other things, but I haven't read a ton into that. So read about it and let me know, folks. So I guess I would say a brown dwarf, which isn't quite a star, it would be the best answer to that. I don't know, Max, what do you think?
That would be my guess. A brown dwarf, white dwarfs are thought to eventually become a black dwarf, so pretty much just this hunk of mass floating around outer space. I don't really know what the temperature of that is, or even if you would call it a star.
Yeah. I also know that none of those actually exist as far as we know. That's sort of a hypothesized thing that could happen, but I think that they calculated out like how long it would take for that to happen, and it would take longer than the universe has existed so far. The universe is about 13.8 billion years old, and it would take longer than that. So, as far as we know, there aren't any yet, which is kind of amazing to think about. um, awesome, great. Thank you all so much for joining us, Max. Anything else you wanted to add?
We certainly covered a lot, and a lot of the stuff that Marissa and I talked about is very complicated. We very much went over the very simple, the kind of the straightforward, the best we could kind of describe to you all, and tried to show you some of the things you might be familiar with or you might be able to see. If you are curious about any of this stuff, types of stars, types of nebulas, black holes, look that up on your own. You have questions that probably Marissa and I haven't thought of or might not know the answer to, and utilizing your own curiosity is going to help you figure out those answers.
Yeah, that is great advice. I completely agree. Well, awesome. Thank you all again so much for joining us. This is a lot of fun. Stay curious, stay safe, take care, and we'll see you next week. I think next week we might have a guest presenter, Max and Dr. Sean, another planetarian from Pacific Science Center. So you're in for a treat for that. All right, fantastic. Thank you once again. Goodbye, everybody.
Yeah.